In this lesson, we are going to determine the equation of a parabola when we are given the vertex, the focus, or the directrix. They're going to give us one or two of those pieces of information, and from that we're going to be able to create the equation of a parabola. Now remember, the equation of a parabola, when we are dealing with directrix and focus kind of questions, there are two different types. There's this one, and then if it is opening left or right, then we use this one. And we've spoken about this in previous lessons. We spoke about how to draw parabolas. So I would highly recommend that you've watched those videos. But in summary, when the x is squared, then it opens up or down. And when it's the y that is squared, then it opens left or right. And then we've also said that, let's say, for example, it opens up, then we know that there's always a focus that's in the middle, or like on the inside, and then there's always a dotted line which is called the directrix. Let's just draw this a little bit better. There's a directrix. And we know that this length from the vertex to the focus is called P, and then this length over here is also P. And then, oh yeah, that's probably the only information that we'll really need. Okay, so let's have a look at how these examples are going to work. So here's the first one. It says, determine the equation of the parabola when the focus is at 0, 2, and the vertex is 0, 0. So the first step I would advise is just go plot those points. That'll give you a good idea whether this parabola opens up, down, left, or right. So if the focus is at 0 and 2, let's go plot that over there, and the vertex is at 0, 0. Now look at that. It cannot open left and right, because if it opens left and right, then the focus would look something like that. And okay, now you need to decide if it opens up or down. So if it opens up, then the focus would be on the inside. If it opens down, then the focus would also be on the inside. So if this is the vertex, then this, and this is the focus, then it would have to open up. Why? Well, if it opens down, then this doesn't make sense, because then the focus is supposed to be here, which is on the inside. So it has to open up so that the focus is on the inside of the graph. There we go. So we know that the equation we are going to use, let me quickly write down two equations, and you need to decide which one we need to use. So that's the first type, or it might be this type. Whoops, that's an H. So we know that when there's an x that's squared, then it's up or down, and when it's a y that's squared, then it's left or right. So we don't want the y squared. So we don't want this one, because that's got a y squared, so we won't use that. So we're definitely going to be using this one over here. Now, let's go fill in the vertex. Remember, the vertex we can find, or that part there is usually the vertex. So this equation, the vertex is at 0 and 0. So it hasn't moved any units to the right or left, and it hasn't moved any units up or down. So if you had to simplify that, you'll just end up with x squared equals to 4py. Okay? Now, so h and k is 0. Now, if we know that this length here is p, right? We've said that before. And of course, there's also a directrix down here at the bottom. But we don't really have to put that in, because the goal of this video is not to show us how to draw them. It's to show us how to find the equation. So this length, if this is 0 and 2, then what would this vertical distance be? Well, that would be 2. So p is 2. So all I do now is I just go fill in p as 2. So x squared is equal to 4 times 2. Now 4 times 2 is 8. And there is the equation. Done. So for the rest of this video, we're just going to be looking at a whole bunch of these. Some of them are going to go left, down, right, all sorts of different types. And some of them are going to have a vertex that's not at the origin, or some of them will be at the origin. So here's our next example. So first step is just to go plot the points, because we need to get an idea of whether it opens up, down, left, or right, because that determines what formula we need to use. So the focus is at 2 and 4. So 2, let's go 2 and then 4. Boom, boom. So the focus is going to be there. Okay. Then they tell us that the vertex is at 2 and 1. So 2 and 1. Okay. So if they are above each other, then we're definitely opening either up or down. Okay. If it was like this, then they would open left or right. So we know that the vertex is here at 2 and 1. So that's the vertex. And the focus always has to be on the inside. So this graph is going to look something like that. You might be wondering, why isn't it facing down? If it was facing down, then we have a problem, because this is the focus, and the focus is always on the inside of the curve. You know, that's the inside, and that's the outside. So it has to be on the inside of the curve. So our graph, whoopsie, we don't want to take that away. So our graph is going to do something like that. Okay, so remember, that means there's two types of equations you could use. You could choose between. Now you got to choose correctly. I'm going to write them both down for you so long. So remember that when it's the x that is squared, that's when it's up and down, and when it's the y that is squared, then it's left and right. So we're not going to use that one, because that's for left and right graphs. Okay, so the first step, let's go fill this in quickly, 2 and 1. So remember, the h and the k helps you to work out the vertex. Now, this graph has moved 2 to the right. Remember, a normal vertex is here at 0, 0. So this one has moved 2 to the right. So remember, right means negative. So you're going to say x minus 2, like that. And then it's moved 1 up. See, 2 to the right and 1 up. So up means negative for the y. Up means negative. There we go. Now, we need to look at this vertical distance. So if this coordinate is 2 and 4, then if you're going from 2 and 1 to 2 and 4, then that's a vertical length of 3. So p is 3. P is 3. Because remember, p is the distance from the vertex to the focus or to the directrix. That's p. Okay? So p is 3. So I'm going to go full p is 3. Like that. And then y minus 1. Now 4 times 3 is 12. And there we go. That can be our final answer. Here's the next one. So here I would just go plot everything that they've given. So they've given us a focus of 2 and 2. So 2 to the right, 2 up. That would be our focus. And then they've given us the directrix, which is at x equals to negative 2. So if you go x equals to negative 2 and you plot that, remember the directrix is always a dotted line. There we go. Okay, so quite interesting. So here we've got our focus, and here we've got our directrix. So it's definitely going to be a graph that goes like that, because if your directrix is like that, then your graph goes up or down, and if your directrix is vertical, then your graph goes like that or like that. So we're definitely turning that way, because the focus is always on the inside of the curve. Okay, so let's quickly look at this distance. So if this is 2 and 2, and this is at x is negative 2, then that vertical distance is 4. So the vertex would be exactly halfway. So half of 4 is 2. So that means that this length, so from this direction, well, let's go 2 this way. So then what you'd find is that the vertex is actually going to be on the on the y-axis, right? Because that's exactly halfway between those 2 points. So the coordinates of this vertex would be x is 0, and the y value would be 2. And the graph would look something like that. So that's important, because remember, there are 2 different equations that we can use. There's this one, and then there is this one. So remember that when the x is squared, that's for up and down parabolas, and when the y is squared, then it's for left and right. So this is definitely going to use this equation, because we're going left and right. So let's go fill that in. Okay, now we can go fill in the vertex. So remember, the x value of the vertex is 0, so this will just be a 0. And then this graph has moved. So remember that a normal vertex starts at 0, 0. So look at this vertex. Has it moved up or down? It's moved up. Now remember, up means negative when you're filling it into this equation. So you're going to put a negative 2 here. That means 2 up. And so x take away 0 is just x. So we can go like this. Okay. Now we just need to go find p. So p is the distance from the vertex to the focus. That's p. Or if you want, you can also find the distance from the vertex to the directrix. That's also p. So if you had to look at this horizontal distance, if you go from 0, 2 to 2 and 2, that is a horizontal distance of 2. So p is 2. So if I then go fill that in, then I'm going to end up with 8 over there. And so that would be the final answer.